doing that. Okay, so since we only have two elements on this one, let's just put them next to each other. So H and Cl are going to go next to each other. And then we want to connect them together. So we're going to draw a line connecting H and Cl. All right, now if you guys remember, if I draw a line, does anyone remember how many electrons that is? That's 2. So if we draw a line, we use 2 of these electrons. So now we have 6 that we still need to draw. Okay, so since we drew a line to connect them, we use 2 electrons to draw the line. We have 6 left that we still need to draw on the picture. All right, now if you guys remember, it's octet rule. So everybody wants 8 other than H. H wants to have 2. So if we take a look at H, since it has a line next to it, that means it already has 2. Okay, but Cl, it has a line next to it. It currently only has 2 as well, but it wants to have 8. So what we're going to do is we're going to put the 6 dots that we still need to draw on the Cl, and that's how we can get Cl to 8. It has 6 dots, and then 7, 8 from the line. And that's what HCl is going to look like. All right, any questions on this? Hopefully not too bad. It's what we kind of left off doing. All right, so let's try a couple more together, and then I'll get you guys started on your assignment. So I'll have you guys actually try this on your own with the person next to you. Let's see if you guys can work it out. CF4. So I want you guys to work with the person next to you. I want you guys to see if you could draw CF4. Now, before you guys do that, I do want to highlight this rule just in case you guys forgot. C is always going to go in the middle of the atom. So when you're drawing and arranging your atoms, make sure you guys put C in the middle. So let me give you guys about 3 minutes to work on that, and then we'll go over it together. Okay, so we're going to be drawing CH4. So we talked about earlier how sorry, we didn't talk about F yet. Never mind. Okay, so C, if you guys take a look on the periodic table, is box number 1, 2, 3, 4. That means the C in CF4 is going to give you 4 valence electrons. Okay, let's go to F now. F is box number 5, 6, 7. And there are 4 of them, so that means that the 4 Fs are going to contribute 28. Okay, so here we'll have a total of 32 valence electrons. Okay. Yeah, because there are 4 Fs. That's correct, yeah. Yeah, so you got to multiply it. Or, I mean, you can technically do 4 plus and then 7 4 times. So 7 plus 7 plus 7 plus 7. That works as well. Okay, but 32. Okay, so kind of a big number, but it actually is pretty easy to put together once we start drawing the structure. So let's mark that CF4 has 32 valence electrons. All right, so I mentioned to you guys carbon is always going to go in the middle of the atom. So we're going to put carbon in the middle. And if carbon is the middle, that means the 4 fluorines, they're going to surround the carbon. Okay, so 4 on the top and on the sides. Okay, again, it doesn't really matter how you orient them. You can make them an X shape if you want, but as long as everybody is surrounding carbon, so that carbon's in the middle, then you're good to go. Okay. All right, now we got to connect them together. So this F is going to connect to carbon. This F is going to connect to carbon. This one as well. So everybody gets connected to carbon. All right, so if you guys take a look, we drew 4 lines, right? If you draw 4 lines, how many electrons did you use? 8, yeah, because every line is 2. So every time you draw a line, you use 2. So you use 2, 4, 6, 8. So that means we no longer have 32. We have 24 valence electrons that we need to draw, okay? All right, so let's take a look at carbon. If you take a look at the carbon, there's 4 lines next to it. How many electrons does carbon have right now? Yeah, it has 8. Because it's connected to 4 lines, it has 8 electrons. So carbon right here is happy because it has 8. But if you take a look at the fluorines, each of them has 1 line, right? So that means they only have 2, but they want to have 8. So I got to give this guy 6 more. And so if you give this fluorine 6, now it has 8, so it's happy. And then that goes to 18. And you guys kind of see how we're going to finish it off, right? We give this guy 6. That's going to get me down to 12. We give this guy 6. That gets me down to 6. And then the remainder I give to fluorine. And so that's how you finish up drawing that structure. Okay, so kind of a harder one, but again, just keep following the rules. Put carbon in the middle, and just make sure everybody got 8. Any questions on how we finished up that one? Okay. We'll do one last one, and then I'll get you guys started on your assignment. All right, so before we start, I want you guys to write down this structure. We're going to do this together, but I want you guys to draw or write down CH3NH2 on your paper. Good catch. And then I want you guys to take a minute just on your own, see if you could count up the electrons first. Okay, I'm going to help you guys draw it because there is a little trick that you guys need to know, but at least try to count the electrons on your own, and then we'll go over in a second. Okay. Sure. Okay, so we got CH3NH2. So if you guys take a look at your periodic table, we already did C and H, so we can just write those down. We know that carbon is 4. We know that H is 1, but there's 3 of them here, so it'll be plus 3. I'm not going to pull up the periodic table, but if you guys counted nitrogen, that should be 5. And then the H's here are 2, because each of them are 1. Okay? Okay, so we'll have a total of 14 valence electrons. So far, so good on that, guys? Okay, so this is the easy part, just counting. Now, if you guys take a look at this structure, it looks really ugly. It looks kind of complicated, but it's actually pretty simple. We talked about this before we went on break, but if you guys ever see elements separated like this, you guys see how there's hydrogens here and hydrogens here, right? If you ever see them separated, it's kind of telling you what the structure already looks like. So what this is telling us is that on the left side of the molecule, there is a carbon, and there are 3 hydrogens connected to it. So what we can do is on the left side of the molecule, we got a carbon, and there are 3 hydrogens that are surrounding it. That's what this is telling us when it separates the hydrogens like that. Okay, and on the right side of the molecule, it's telling us that there is a nitrogen, and there are 2 hydrogens next to it. So nitrogen like this, and I'll put one on the top and one on the side. It doesn't really matter how you orient it. If you want to put it on the top and the bottom, that's fine as well. It doesn't really matter. Okay, as long as there are 2 hydrogens next to the nitrogen. Okay, so that makes sense, guys? Elements separated, it tells you which side of the molecule they're going to be on. So if you separate them, it's actually easier for you guys. And then from here, you guys can kind of already see what it's going to look like, right? Just in your mind. So let's draw the line. So I'm going to draw 1 line, 2 line, 3 line. Okay, another line and another line. This is what it's telling us. Okay, but if you guys remember, it's 1 molecule, so everything needs to connect. So we need to connect the carbon and the nitrogen as well. So let's count up our lines. We drew 1, 2, 3, 4, 5, 6 lines. That's 12. That means we only have 2 electrons left to draw. So we just need to look for the one that still needs 2 electrons. So if you take a look at this molecule, which element needs 2 electrons still? Yeah, N, because it only has 3 lines, so that's 6. Well, we can get it to 8 by giving it 2 dots. And there you go. That's what that structure is going to look like.